Lesson 97 is about the Pythagorean theorem. But first let's start with a little bit of a review of angles and triangles. Now an angle, we define an angle as being formed by two half lines. So that means like an endpoint, and then it continues on in one direction forever. And then another half line, they join, they have a common endpoint. That's what we define an angle as. Two half lines or rays that have a common endpoint. Now a triangle, it's called a triangle because it has three angles in it. And if you recall, the sum of the interior angles, those are the angles on the inside of the triangle, the ones that I have put the red little curve marks on. The sum of those three angles for any triangle add up to 180 degrees. So that's just a special property of triangles, that the sum of the angles on the insides add up to 180 degrees. Now, right triangles, those are triangles that have one side that's a 90-degree angle, and we designate that by putting a little box at the corner. And we could label the sides. We could call this side A, this side B, and this side C. Now that side that's opposite the right angle, that's always the longest side of a right triangle, and it has a special name. It's called the hypotenuse. The only time you'll ever hear that word really is when you're talking about the side opposite a right angle, a 90-degree angle in a triangle. That's called the hypotenuse, and it has a special name. It's the longest side of a right triangle. Another special property of right triangles is that if you square the hypotenuse, it's equal to the sum of the other two sides squared. C squared equals A squared plus B squared. That's what the Pythagorean theorem is. This theorem was developed a long time ago. In fact, around 600 years before Christ. So this is a really old formula, and some guy named Pythagoras, he was the one who developed this theorem. Supposedly the Egyptians knew about it in 2000 BC, 2,000 years before Christ. But Pythagoras is given the credit for it because he was able to make a formal geometric proof. Now that Pythagorean theorem, that will come in handy when you're working with a right triangle. Say you knew two of the three sides of a right triangle, you could figure out that third unknown side by using the Pythagorean theorem. Now there are some special Pythagorean triples, they're called. They're right triangles that you come across fairly frequently, such as a 3, 4, 5 right triangle. And that's just a good one to remember, because if you had a triangle and you knew two of the sides of it, they were 3 and 4, you could figure out the third one right away. You'd say, oh, well, 3, 4, 5. Or you could use the Pythagorean theorem. And you can notice there that the hypotenuse is 5, so that would be 5 squared is equal to 4 squared, which is 16, plus 3 squared, which is 9. 25 equals 16 plus 9, which is 25. And that proves right there that the Pythagorean theorem does work. Another good right triangle to commit to memory is a 5, 12, 13 right triangle. And then a third one to remember is an 8, 15, 17 right triangle. And these are just good ones to remember because all of the sides are whole numbers. There are not very many right triangles that all three sides are the whole numbers on. So a 3, 4, 5, a 5, 12, 13, and an 8, 15, 17 are good ones to commit to memory. Let's go ahead and do some practice problems. Look at practice problem A. I want you to find that unknown side. And we see that we have a right triangle, so that right away should tell us that we can use the Pythagorean theorem to solve for that unknown side. And it's the hypotenuse, so we would say c squared, well actually let's just write down the Pythagorean theorem first. C squared equals A squared plus B squared. It's real important for you to write this down because that helps you commit it to memory. So there's the Pythagorean theorem. Now let's go ahead and substitute in. C squared is equal to A squared. It doesn't matter which one we use for A. We'll just say 8 is A, and we'll say 64 plus 4 squared is 16. And then we'll have C squared is equal to 80. Now, remember what we do? We're working with the difference of two squares theorem, and that was basically preparing you for this lesson. So when you have C squared equals 80, hopefully you know now that you would just say C is equal to plus or minus the square root of 80. Now, we're working with distances here. C is a distance, and we wouldn't have a negative value for that side, so we don't worry about the negative, and so we'll just say square root of 80. And we could simplify the square root of 80. Think of a factor that you know the square root of that you could factor out of 80, and that would be a 16, right? So you can say square root of 16 times the square root of 5. And so we end up with 4 times the square root of 5. That's the length of C. We don't have to have a decimal result or anything. We can just leave our answer like that. 4 times the square root of 5. Look at B. I want you to find side X. So we have a right triangle there, so we know we can use the Pythagorean theorem. Let's go ahead and write it down. C squared equals A squared plus B squared. Now, we know what the hypotenuse is. That's C. So we can say 11 squared, or 121, is equal to A squared plus B squared. It doesn't matter which one we say is A and which one is B. I'll say the A is 10, so that would be 10 squared, or 100. And then B squared is just the X, so we'll say X squared. Subtract 100 from both sides, and we'd have 21 equals X squared. And so X would equal the square root of 21. And that would be the length for X. We can't simplify that anymore, so that's our answer, square root of 21. Look at practice problem C. We have an unknown side there. We have a right triangle, so we know we can use the Pythagorean theorem to solve it. Now, in that one, there is actually a Pythagorean triple there. And Pythagorean triples can be multiples of the ones that we discussed earlier. So it could be a multiple of a 3, 4, 5, a 5, 12, 13, or an 8, 15, 17 right triangle. It's a multiple of one of those. Pause the CD and see if you can figure it out. So first what we want to do is say C squared is equal to A squared plus B squared. And we have our hypotenuse, it's 10, and so we'd say 10 squared, or 100, is equal to A squared. I'll just use that for the H. I'll say H squared plus 6 squared, or 36. We subtract 36 from both sides. That cancels, and we get 64 is equal to H squared. And so H is equal to 8. And hopefully you recognize that, and you wouldn't have had to use the Pythagorean theorem. If you had recognized that that was an 6, 8, 10 triangle, which is just a multiple of a 3, 4, 5, just multiply everything by 2, you wouldn't have had to use the Pythagorean theorem. So that's a good reason to memorize those 3 Pythagorean triples, we call them. A 3, 4, 5, a 5, 12, 13, and an 8, 15, 17. So the Pythagorean theorem, that's equal to the hypotenuse squared plus the squares of the other two sides added together. C squared is equal to A squared plus B squared. Okay, well that's all for lesson 97.